Consider the cubic function g of x. State the transformations that were used to create g of x from the parent function f of x. So g of x here, actually let's start with f of x. F of x is where we start, right? That's the basic parent function, x to the fourth, quartic function. And through some sort of transformation or transformations, we arrive at g of x. And so the way that we want to go about figuring out the transformations is each transformation is going to change our function in some way. And the easiest way to really visualize the transformation is to graph it. And so let's start by just graphing our quartic function. That's a decent job, I suppose. And let's think about what's the first transformation that was made. So if we start with x to the fourth, and then we consider, okay, what is happening to this function? Well, let's first work inside the exponent, right? That's always where we want to begin, PEMDAS, inside the exponent, inside the parentheses. And we notice that instead of x to the fourth, we have x plus 1 to the fourth. So the first transformation that we will make is we'll go from x to the fourth to x plus 1 to the fourth. And what did this do to our function? Well, notice here the root was at 0. Right? We had a fourth degree root at 0. And now this root is where? This root is at -1. And so our function would move so that now the root is at -1. And so what was the transformation that occurred here? This was a translation of 1 unit to the left. Okay? Then what happened? Then notice that instead of just being x plus 1 to the fourth, we have a negative out front. So we would multiply by a negative. And what does this have the effect of doing? Well, consider that everything to the fourth power is going to be positive. And what happens when you multiply any positive number by a negative? It will become negative. And so everything that was once positive now becomes negative, and the transformation is a reflection. A reflection over, and this is important to state, what did it flip over? It flipped over the x-axis. All right, we're almost there. The last thing that we have is everything that we've taken to the fourth, we now subtract 3. So our last transformation is going to complete everything. We have negative x plus 1 to the fourth. And we're going to now subtract 3. Well, let's just think about what happens at the root, at -1. Well, I plug in -1, and I'll get -1 plus 1, which is 0, to the fourth power, which is 0. Subtract 3. So what was once 0 is now 3. Everything has simply moved down three units. And so this is a translation 3 units down. So those are the transformations. It's very helpful to graph them. I recommend graphing everything so that way you can check that your transformations have made sense. Now the next thing that we want to do is we want to sketch a graph of the function, but notice we've already done this. Thanks to all the transformations that we've done, we already have our graph sketched. So we can go to our final sketch here, we can re-sketch it over to the side, nice and neat, so that anyone who is looking for the final sketch of the graph could see it. And last but not least, part C, we want to decide whether this function is even, odd, or neither. Now, let's first think about whether it could be even. Could it even possibly be even? Well, it has a fourth degree. It's a fourth exponent, so there's a chance it's even. Is there any chance that it's odd? there's no chance it's odd. Since we don't have an odd exponent, there's no way that we'll ever have that opposite answer situation that we do, say, with a cubic polynomial, where if I'm at positive 1, I have positive 1, and if I'm at negative 1, I have negative 1. I know that's not going to work. So the only thing I could test for is whether it is even. And to test whether it is even, I would like to know whether f of x is equivalent to f of negative x. How would I test that? Well, I've got to actually test. I know what f of x is. It's negative x plus 1 to the 4th power minus 3. And what is, and I'll put a question mark here because we don't know yet, what is f of negative x? Well, now I would plug in negative x, and I would have negative x plus 1 to the 4th power minus 3. And let's just consider, are these things equal? And it seems like there's a difference, right? We have a negative x here. Is that going to change our function? Well, imagine what would happen if you plugged in 1 for x. So here we'd have 1. 1 plus 1 is 2. 2 to the 4th power is 8. Times a negative would be negative 8 minus 3, which would be negative 11. What about here? If I plugged in 1, I would have negative 1 plus 1, which is 0. 0 to the 4th is 0, minus 3 is negative 3. So these are, in fact, not equal. Okay? These are not equal, and so the function is neither odd nor even. Remember that you can prove that something is not even or not odd with a counterexample. For example, if I plug in, like I did there, if I plugged in 1 for x, that would be allowing me to prove with a counterexample. I can't prove something is the case with just one example. I'd have to prove it for all x. But using one counterexample, I can show that it does not happen, or that it is not even or not odd. Now, I want us to pay attention to the quick way that we can tell. So let's start with x to the 4th here. I want to highlight x to the 4th again. This is an even function. How can you tell? Look that it's symmetric on either side of the y-axis, right? If I plug in, notice that this statement just says that when I plug in some value x, it is the equivalent to plugging in the opposite of that value. So if I were to plug in 1, I would get 1, and if I were to plug in negative 1, I would also get 1. I plug in the opposite value, I get the same answer. And that's obvious because it's symmetric with the y-axis. But once we've transformed our function, it's not symmetric with regards to the y-axis. And so, for example, if I were to plug in positive 1 over here, notice that my function is way out here, right? 1 plus 1 to the 4th would be 8, minus 3 would be 5. And so, I'm sorry, negative 8 minus 3 would be negative 11, so I'm down here. But if I were to plug in negative 1, the opposite, I would be at negative 3. And so it's not going to give me the same value. So it's a quick and easy way to see if it is symmetric about the y-axis, then it will be even. And if it's not, there's no way that it can be even.